Hi class. Tonight we're going to talk about end behavior. Now I know I have already touched on end behavior, but tonight's video is going to be on how to use correct notation. So in order to write end behaviors. So we're going to look at first our even degreed functions. So notice that our quadratic, that's going to be our even degreed function here. So notice that on the left hand side, as x goes to negative infinity, as x moves this direction, y is going to positive infinity. And going the other direction, as x moves towards positive infinity, y is moving towards positive infinity. And that's how we get our up for this end behavior. So let's look at how to write this end behavior. So for an even degreed function, okay, and positive coefficient, we're going to write as x approaches negative infinity, that's the left-hand side that I showed you, f of x, which is y, is going to approach positive infinity. That's your up on your left. On your right, x is approaching positive infinity, going to the right. F of x, your y, is going to positive infinity. Again, as x goes to negative infinity, y is going to positive infinity. On the right, as x approaches positive infinity, y is approaching positive infinity. Okay, so what if the coefficient on our degree term is negative? Notice it's down on the left and down on the right. So as x goes to negative infinity, f of x is going to negative infinity. And going to the right, as x approaches positive infinity, f of x is approaching negative infinity because it's going down. So if we have an even degree term, or degree function, excuse me, and has a negative coefficient, so going left, that's what this part means. As the function moves left, as the domain is moving towards negative infinity, the range, the y values, are approaching negative infinity because we have a negative coefficient. We're going down. We're going down. And then going to the right, as x approaches positive infinity, going to the right, the function is going down. This was up on the left, up on the right. This is down on the left, down on the right. Okay, so let's take a look at odd now. So if we have an odd function with a positive coefficient on the degree term, so let's go positive and let's go cubic. So notice that on the left it's going, as x goes to negative infinity, y is going to negative infinity. As x goes to positive infinity, y is going to positive infinity. Well, I didn't make the 5-minute mark. Sorry, guys. I tried. Okay, as x went to negative infinity, y is going to negative infinity. That would be down. This means to the left. This means the function is going down, decreasing. Okay. Odd function, odd degreed function, negative coefficient. Let's go back. This time we have a negative. So notice, as we go to the left, function is going up. As we go to the right, the function values are going down. So why don't you write this for me, and I will check this off when I check your video notes to see if you wrote the notation correctly. So this is the end of this video on end behavior. The following few minutes is going to be a review for your quiz tomorrow. So you're welcome to stick around, or you can sign off right now if you have more pressing things to do. Okay, quiz review. So what you need to know for your quiz tomorrow is you need to be able to, number one, you need to be able to give me the degree of the polynomial. And remember, degree means the highest exponent. Number two, you're going to need to be able to identify a coefficient. So remember, the coefficient on a term is the number part. So if I had 3x squared minus 4x to the fifth plus x, the coefficients would be 3, negative 4, and 1. And you also need to know how to order these, where this term would be first, then this term, and then this term. Third, you'll need to ID or identify the constant. So the constant in this polynomial here is 0. Since there is no number on the end, it would be 0. But if I had a constant on the end, for example, plus 4, that would be your constant, 4. Number 4, you'll need to know how to describe end behavior. End behavior. So that's what this video was about that we just went over a few minutes ago. 5, you'll need to know how to expand a polynomial. So if you were given a polynomial in factored form, let's say x plus 3 times x minus 2 squared, for example, you would need to know how to multiply these out. So first thing you would want to do is you would want to probably square the x minus 2. So I would FOIL this, first terms, outer terms, inner terms, last terms. Simplify that up. And then you would need to multiply these together. And we learned how to do that with polynomial operations. The next thing you will need to know how to do is how to determine zeros. Remember, zeros is another name for roots. You'll need to know how to determine the zeros from a graph and from an equation. And then lastly, you're going to need to be able to graph a polynomial by hand. Now that's without a calculator. Okay, that's it. I'll see you guys in class tomorrow.